All right, we're back at it. I'm recording this on Halloween and Diwali, both today. Happy Thursday, my friends. All right, we're gonna go through and do some questions here. This review for our quiz. Our quiz is next time I see you, hopefully with a big smile on your face. The first one, it says, in Seattle, there's a neighborhood called Denny's Triangle because of its triangular shape. BFS John, Saharsh, and Bowen each live at a vertex of the triangle. So they each live at a vertex. Boom, got it. Boom, boom, boom. If they want to meet up at a restaurant that is equidistant from their houses, so equidistant from the vertices, which POC should they use? And that is the circumcenter. The circumcenter is equidistant from the vertices. We did lessons on that. But one thing I want to remind you is that in-center starts with the letters N. It is inside, always inside, no matter what kind of triangle it is. And inside has the word side. It is equidistant. I don't want to write all that, but it's equidistant from the sides. The in-center is inside, equidistant from the sides. That means that the circumcenter is equidistant from the vertices. Those are the two that people mix up often. So the next one says that there are 3 walkways that form a triangle, and the interior of the triangle is grass. The owner wants to put a sprinkler so that it sprays in a circular motion that covers as much grass as possible without getting any of the water on the walkways. So would walkways be points or sides? On all these questions, you need to picture a triangle and ask yourself, there's different parts. Are they talking about sides of a triangle or vertices of a triangle? If it's vertices, that's circumcenter. If it's sides, that's in-center. And then finally, if you were to balance a triangle on the tip of a pencil, which point would you need to accomplish this? And that is the centroid. The center of gravity is where you would balance it. That's where the mass is equally distributed around that point. I'm not going to go over all these. If you remember the saying I told you guys, an odd peanut butter cup may contain apple butter instead. Peanut butter cup is one I really hang on to. Or Ayo, Ayo, altitude, orthocenter. You got to know these answers, though. You can't mix these up. Get them right. All right, sometimes always never can be pretty tough. Let me open up my little situation. Real quick recap. This is a scalene acute triangle because every line is a different line. They're distinct. Like all these blue altitudes are just altitudes. All these pink angle bisectors are just angle bisectors. All these black medians are just medians. So in a scalene triangle, a median has median properties, period. An altitude has altitude properties, period. If I were to change it to make it isosceles, so that this is the green line's a perpendicular bisector. If a perpendicular bisector goes through the vertex and it becomes isosceles, now I have one set. I just have to draw one line, B to F. That is a median. It's an angle bisector. It's a perpendicular bisector. It's an altitude. It is everything right now. Now from the other corner, pink, blue, black, green, are they still different lines? Yes. So they all line up from the vertex angle. This is an isosceles triangle. I also know it's acute because all 4 special points are still inside the triangle, G, J, I, and H. If I tighten this up and make it equilateral, check it out. Do you think I can do it? Can I make it equilateral? What do you guys think? I bet I can do it. Doop, got it. Pretty close. When it's equilateral, what happens is all of the points line up. That means that this point in the middle, not really middle, but that point is all of the points. It's a centroid, it's an orthocenter, it's a circumcenter, and it's an in-center, and it has all the properties. That means it's equidistant from the sides, it's equidistant from the vertices. It's all of them with all of the properties. So on an isosceles triangle, we have 4 lines become one from the vertex angle. When it is equilateral, they line up from every corner, and now all the points line up. So this is a big deal. That means, like right now, the centroid is equidistant from the sides. It's not usually, but it is right now. And if I make this an obtuse triangle just so you can see it, now I have 2 points outside the triangle. Remember, the in-center is inside all the time, and the center of gravity is inside all the time. So the centroid and the in-center never leave. The circumcenter and the orthocenter can and will on an obtuse triangle. And then quickly, if I make it a right triangle, now the circumcenter and the orthocenter are on the triangle. Right on, dude. And if you look at these altitudes, the blue lines are altitudes, they become the legs of the right triangle. Remember, when it's obtuse, they can be outside the triangle, and when it's a right triangle, they are the triangle. They become one with the triangle. That's as quick of a recap as I can give. I have other videos. Go watch them. But you can't do these if you don't know that. All right, the incenter is the intersection of three altitudes. Altitudes hit at the orthocenter, but they can if it's equilateral. So sometimes the centroid and the incenter are located in the triangle, always. Centroid, center of gravity, incenter, inside, always. Isosceles triangles are equilateral. Still, I gotta remember that. Yes, isosceles means at least two, equilateral means three. If I have at least 2 bananas, could I have 3? Yes, I could, sometimes. In an isosceles triangle, the circumcenter is the center of gravity. Well, the circumcenter is only the center of gravity in an equilateral triangle when all 4 points become one. So the question really becomes, can an isosceles triangle be equilateral? And we just said that's sometimes, so this is sometimes. In a scalene triangle, the perpendicular bisector of AB goes through the vertex. If it is scalene, can a perpendicular bisector go through a vertex? No. The only time a perpendicular bisector will hit a vertex is if it's an isosceles triangle. It'll happen once, and if it's an equilateral triangle, it'll happen 3 times. In a right triangle, angle bisectors hit the midpoint of the opposite sides. Yes. If it was a right isosceles triangle, it could happen 1 time. Yes, sometimes. In an equilateral triangle, I could draw every special segment by only drawing 3 lines. Yes, I just showed you that. All of those messed up, that messy picture, that wild picture became real clean with 3 special segments representing all 12. The orthocenter is equidistant from all 3 vertices. If it's equilateral, it can. The orthocenter and the circumcenter become the same place. And then obtuse triangles are isosceles. Well, yes, we've talked about that before. Sometimes they can be, but they don't have to be. All right, let's do some questions here. It says, given triangle ABC with E between B and C. So E is between B and C. AE is an altitude. Oh, I should have read that first, so I'm going to draw an altitude. AE is an altitude. And then it says the measure of angle BAE, that would be this angle. Angle is this. Angle B is 70, that's this one. And then the side AC is 10x. All right, well, what do these 3 angles, 90, blue, and brown, have to do? They have to add up to 180. And because this corner is already 90, I know that brown plus blue have to add up to 90. So I know that 5x minus 10, blue, plus 70, red, have to be 90. So 5x plus 60 has to be 90. So 5x has to be 30. And x has to be 6. So it says find x, that's 6, and AC. Well, they said AC is 10x. So 10 times 6 would be 60. So AC would be 60. So that's an altitude situation. We got this, guys. Given triangle ABC, so I'm going to draw a triangle ABC with E between A and C. So with E between A and C, and it's an angle bisector this time. So it says BE is an angle bisector. It says the measure of angle ABE. So let's see, we'll make that one pink. ABE would be this one. And then brown would be this one. Oh, try to make it brown. This one. And because it's an angle bisector, we know that those are going to be equal. So we know that pink and brown are equal. X squared plus 5 is equal to 2x squared plus x minus 25. This is a quadratic equation. We got to make one side 0, so I'm going to do minus x squared, cancel that out. Minus 5, let's do that next. Let's do the plus x first, and then minus 5 would give me minus 30, cancel that out. So we've got x squared plus x minus 30. What factors of 30 subtract to equal x? And that, sorry, to equal x, to equal 1. So what are the factors of 30 that subtract to equal 1? They're going to be 6 and 5. And because it's plus 1, I need plus 6 and minus 5. And then what would make x plus 6 equal to 0? That'd be negative 6. What would make x minus 5 equal to 0? That would be positive 5. So x equals negative 6 and positive 5. When I plug those in, plug in 6, I would get 36 plus 5, that's 41. That's okay, that's acceptable. Plug in 5, that would be 25 plus 5, that's 30. That's also acceptable. So wait a second. Oh, it says find the largest possible. Well, the largest one would be when x equals 6. So if this is 41, that means both of these are 41 when x equals 6. Sorry, when x equals negative 6. Which makes the whole corner, angle ABC, 82 degrees. So if they did not say this, if that was gone, we would have to give both answers, 82 and 60. But because they told us only the largest one, that left us with only 82 as an option. All right. Ooh, some more, sometimes, always, never. I love them. The in-center is equidistant from the sides. In-center, inside, equidistant from the sides. Let's go. The in-center is equidistant from the vertices. If it's equilateral, yes. So sometimes. A perpendicular bisector goes through a vertex and a midpoint if it's equilateral. But perpendicular bisectors do not have, or if it's isosceles, it happens once, sorry. But perpendicular bisectors do not. If it is scalene, that will not happen. An isosceles triangle has exactly one 60-degree angle. Never. If you have an isosceles triangle and you pick any angle here, let's say we call this one 60. Well, 180 minus 60 is 120, and these have to be equal because it's isosceles, so they're both 60. Divide by 2 is 60. If one of these was 60, it ends up being the same situation. I bet you can figure that out. So can you have exactly 160? No, you cannot. You either have 3 or you have 0 if it's isosceles. Now, a scalene triangle could have exactly 1, but not an isosceles triangle. Can obtuse triangles be scalene? Can you have an angle greater than 90 and all of them be different? Yes, you could have like 100, 20, and the other angle would then be 60. So yes, it can happen, but it doesn't have to happen. An equilateral triangle is isosceles, always. Remember that isosceles means at least 2. So does an equilateral triangle have at least 2 equal sides? Yes. In a scalene triangle, the centroid, it's scalene, the centroid is equidistant from the vertices. No. If I had said circumcenter, yes. And because it's scalene, we know that they're not lined up. Isosceles, sometimes. Equilateral, always. Scalene, never. In a scalene triangle, this is impossible. In an isosceles triangle, the angle bisectors intersect at the orthocenter. Sometimes. This only happens if it's equilateral. Angle bisectors usually meet at the incenter. But if it's isosceles, could it be equilateral? Yes. So sometimes. The orthocenter of a right triangle is in the triangle. If it is a right triangle, the orthocenter is on the triangle, not in the triangle. Literally one letter changes this answer, and it has to be never, because it is on the triangle, not in the triangle. All right, we got some coordinates up here. For triangle ABC, we're going to find the coordinates of x if XC is a median. Oopsies. So it's called triangle ABC. So if it's called XC, X is the midpoint of the opposite side. How do I know that? because C is one of my vertices, and medians have to start at a vertex. So it's from C to X. This is what it's going to look like. X is the middle of the side AB. So effectively what we're doing is getting the midpoint of AB. Medians hit the midpoint of the opposite side. So the midpoint of AB, 10 and negative 2, divide by 2. 10 and 12, divide by 2. You add and divide by 2. I added 10 and negative 2, which looks like 10 minus 2, because what is 10 plus negative 2? Well, it's 10 minus 2. When I say add two numbers, it's like you're combining them. You're just combining them. So the first one is 8 divided by 2 is 4, and that's 22 divided by 2 is 11. So it's 4, 11 for that one. Got it. Find the slope of the altitude that starts at vertex B. I'm going to use the same picture. The altitude would start at B and go and be perpendicular to the side AC. Whew! So we got to know the algebra skills and we have to know the definitions. If it's perpendicular to AC, I can get the slope of AC. So I'm going to go up here and do that. I'm getting the slope of AC. 10 to negative 14, and you can do slope any way you want, but I'm going A to C. 10 to negative 14 is negative 24. 10 to 1 is negative 9. That would be, divide by 3 would be 8 thirds, so, and that's positive 8 thirds. So AC, the slope of AC is 8 thirds, so we want the opposite reciprocal, negative 3/8. Perpendicular lines will always be opposite reciprocals, their slopes. So we know that our altitude is perpendicular to AC, so we got the slope of AC and made it perpendicular. That's the process. We got to get that down. And then finally, the slope of perpendicular bisector for AB. I'll draw another triangle just so we have it here, so it's a little bit cleaner. I'll try to draw a triangle. Notability, come on now. So it's called ABC, and it's the perpendicular bisector for AB. So it has to be perpendicular at the midpoint. So it's going to look something like this. Midpoint, perpendicular. Just like the altitude, it is perpendicular to the side AB. Last time it was AC, but it's the same idea. I can get the slope of AB and make it perpendicular, which is what I'm going to do. So now I'm going to go up here and get the slope of A to B. It's getting real messy. I'll make it pink so we can see it better. So A to B would be 10 to 12, which is plus 2. 10 to negative 2, which is negative 12, which is negative 1/6 when I simplify it. So I'm getting the slope of A to B. The slope of A to B is negative 1/6. But we want the perpendicular slope, which would be positive 6. It has to be perpendicular. A perpendicular bisector will be perpendicular to the side. And it says, in the following, solve for W, X, Y, and the perimeter of deaf. Are you deaf yet? Let's go. There's a lot going on. This is the newest thing we just learned. So we have lots of things to figure out. The new rule is about mid-segments. These are mid-segments. How do I know that? Because it hits a midpoint on the left, it hits a midpoint on the right. It hits a midpoint down here as well. So really, every single segment here, like all three of these pink segments are mid-segments. And there's two rules for mid-segments. The mid-segment is half its base and parallel to its base. So we're going to use those properties. And if it's half its base, let me just make up a number real quick. Let's pretend that this is 10. That would make this entire side 20 because it's half its base. But because this is a midpoint, this would be 10 and 10. So if this is 10, all three of these things are 10. They're all half this base, if you think about it. And then, of course, different mid-segments have different bases. So like if this mid-segment was 10, now these are 10. All right, so let's go through and fill out what we can. First, we know that these two things are going to be equal because F has to be a midpoint. So I can solve for that pretty quick. Let me use a different color. 3y minus 10 has to equal 38. And so 3y has to equal 48. So y has to be 16. Got it. So we know that these two parts are equal because F is a midpoint. Then we'll go pink here. This is the mid segment for this side, which means it's also going to be 38. Those are going to be equal. They're both half of the same side. So 2x plus 12 has to also equal 38. So 2x would equal 26, x equals 13. All right. From there, what else do we need? I got x, I got y, I need w. Well, w is an angle, and the way we're going to get angles is with parallel lines. So I'll go purple. Is that a good choice? Oh, that's a better choice. I'll go this bright green. That looks fun. So it's talking about the angle right here, this w. That's kind of in an awkward position. There's a few ways to get it. If you look at it, if you use parallel lines, it would be the same as this angle. That's one way we could think about it. If you go this direction, it's the same as this angle. That's another thing we could do with it. That might be kind of hard. Or we know that these three angles have to add up to 180. There's a few ways we can do it. What I'm going to do is if these two lines are parallel, and they are, remember mid segments are parallel, then these corresponding angles are going to be equal. That's going to be 23. And then if you go over here, these two lines are also parallel, so this is going to be 59. Those are corresponding angles. And so 59 and 23 and W have to add up to 180. W plus 59, oh dear, plus 59 plus 23 is 180. So 50, 70 plus 12 would be 82 equals 180. So W equals 98. So this angle is 98. And then lastly, it says, what is the perimeter of diff? Well, if this is 38, then this is 38. If this is 15, then this is 15. And if this is 66, then these are both 33, and this is 33. So the triangle would have to be 33 plus 15 plus 38. And that would be 30, 40, 70, 78, 86. And that would be 86. Yes, we got it right. Perfect. So mid-segment rules coming at you. Nice. Oh, that's the whole thing. Guys, that was a lot of fun. Hopefully that was helpful. Make sure you come in for help if you need more help on top of that. I'll see you next time.